All right, we have part two of completing the square. This is a continuation of what we learned earlier, and I just have two different types of examples I wanted to show you so that you can complete your work. So we've been talking about, our first one just said x squared plus bx plus c, because we were assuming a, the coefficient of x squared, was equal to 1. Well, now what happens when a is not equal to 1? What happens when there's a coefficient in front of x squared? Well, in order to use the completing the square method, you have to have a equal to 1. So the way we would take care of this is we would divide by the coefficient. So we're going to divide everything by 2. This is going to leave us with a equal to 1. So now we'll have x squared minus 7 halves x plus 5 halves is equal to 0. So again, this is just like a regular problem. There are some fractions, but no big deal. Let's go ahead and move the 5 halves to the other side. Because remember, we want the constant on one side, the x squared and x term on the other. And these are going to cancel out, and we're left with x squared minus 7 halves x, leave our space, is equal to negative 5 halves. So same thing applies, even though it's a fraction, nothing too scary. If we need to figure out half of 7 halves, well, let's just go over here, scrap paper. If you have 7 halves, and this is negative 7 halves, and you want to find half of it, multiply by half. So we're going to end up with negative 7 over 4. So half of 7 halves is negative 7 fourths, or negative 7 halves. So we are going to, this is what we're going to add to both sides. So this was our step 1. Remember, we took half of b, and then we need to square it before we figure out exactly what we're going to add. So we got the negative 7 fourths. Now we need to square it. This is b, half of b squared. And this is going to be equal to, exactly as you see, square the top, square the bottom. So we're going to end up with 49 over 16. Now, this is actually what we're going to add to both sides. So we have plus 49 over 16 to the left and plus 49 over 16 to the right. That means this is going to be a perfect square binomial now, and it's going to be x minus 7 fourths squared, and it's going to be equal to, if you compute this, you're going to end up with 9/16. To solve, take the square root of both sides. The square root of anything squared, it goes away. X minus 7 fourths is equal to plus or minus, square root of 9 is 3, square root of 16 is 4. So we have to add 7 fourths to both sides to finish out. So x is equal to positive 3 fourths plus 7 fourths, or x is equal to negative 3 fourths plus 7 fourths. So if we figure that out, our answers are going to be 1 and 5 halves. So we'd write them as 1 and 5 halves. Here, this would have been the, remember you have the same denominator, so you just add the numerators, add the numerators, and keep the denominator the same. All right, another example. Let's try 3x squared plus 10x minus 8 is equal to 0. Take a moment, pause the video if you'd like, try it out, and see if you get the same answer. All right, you should be back. Let's go ahead and divide everything by 3, because we need to get the x squared term coefficient equal to 1. So we're left with x squared plus 10 thirds x minus 8 thirds is equal to 0. Let's add that 8 thirds to both sides. Then we have x squared plus 10 thirds x, leave our space, is equal to 8 thirds. Now we need to figure out half of 10 thirds, and if you do that like I showed you earlier, you will end up with 10 over 6, which you can simplify to 5 over 3. So we are going to add 5 thirds to both sides. This then simplifies. Let's see. Wait, I made a mistake. Nah. Hopefully somebody caught it. If not, look at what my mistake was. We shouldn't be adding 5 thirds to both sides. I just took half of b. I didn't square it yet. So this is real live time video recording. There's no editing here. So when I took half of 10 thirds, I got I'm going for the gusto here. 10 thirds times a half. So we're going to end up with 10 over 6, and this is where I was saying it reduces to 5 thirds. But then we need to square 5 thirds before we add it to both sides. So we should square it, which means we will then be adding 25 ninths to both sides. So plus 25 ninths plus 25 ninths. There we go. That looks better. All right, so here we have a perfect square binomial, which is going to be x plus 5 thirds squared. And if we compute everything on this side, we're going to end up with 49 ninths. Taking the square root of both sides to finish solving. Scoot up a little bit. We end up with x plus 5 thirds, because the square roots cancel each other out, is equal to, and our radical properties tell us we can just take the square root of the top, square root of the bottom, so it equal to plus or minus 7 thirds. Of course, we need to subtract this other 5 thirds from both sides. So x is going to be equal to plus or minus 7 thirds minus 5 thirds. Two answers. X equals 7 thirds minus 5 thirds, or x is equal to negative 7 thirds minus 5 thirds. Once you combine those, you'll see that your final answers are negative 4 and 2 thirds. All right, that's all for those types. Let's go ahead and do this last examples, 2 more examples, and this is when your equations are going to end up with imaginary solutions. So the letter I is coming back into play. So these are equations with imaginary solutions. Still, we're solving by completing the square. So our example is x squared plus 8x plus 22 is equal to 0. Now that we're used to these, I'm just going to go a little bit faster. And again, if you need to stop it and rewind it and pause it, by all means, please feel free to do so. That's why I'm making these for you. So I subtracted 22 from both sides. I end up with x squared plus 8x blank is equal to negative 22. Take half of b, square it. We're going to add 16 to both sides. This turns into x plus 4 squared, which is equal to negative 6. Now that we know how to deal with negative square roots, this is not a problem anymore. The square root of x plus 4 squared, of course that's just going to be x plus 4. And now we're going to have plus or minus square root of negative 6. Well, how can I break that down? Well, I know I can break down the square root of negative 6 into negative 1 and 6, and that would bring out my I. So the square root of negative 1 breaks down into, or negative 6 breaks down into negative 1 and 6. And remember, the square root of negative 1 is I. So I can rewrite this, x plus 4 is equal to plus or minus I root 6. All right, almost done. We just need to get that, subtract that 4 from both sides. So finally, we'll have x is equal to negative 4. I'm going to put the 4 first, plus or minus I root 6. If you broke those down, your two answers would then be negative 4 plus I root 6, or negative 4 minus I root 6. There we go. One last example. If you have questions, make little notes on your notes so that you can come in and ask me. All right. Final example for tonight. Example 2, x squared minus 6x plus 25 is equal to 0. We know we need to subtract 25 from both sides. So x squared minus 6x is equal to negative 25. What am I going to add here to both sides? Half of b. So b is negative 6. Half of that is negative 3. Squared is 9. So I'm going to add 9 to both sides. Once I do that, this factors down into x minus 3 squared, which is equal to negative 16. Square root of both sides. X minus 3 is equal to plus or minus 4i. Add 3 to both sides. X is equal to 3 plus 4i, or x is equal to 3 minus 4i. So when we write our final solutions, we have 3 plus 4i and 3 minus 4i. All right, you only have 2 problems to complete on your own. Problem number 1 is solved by completing the square. Both of them are 3x squared plus 14x minus 16 is equal to 0. And the second one is x squared plus 2x plus 2 is equal to 0. So try these out on your own and bring them in tomorrow. Thanks.